Alright, so this lesson we're going to talk about complex numbers. So the very first learning target is that you're going to be able to recognize a complex number to start with. And then once you realize that you're dealing with complex numbers, you'll be able to perform any operation on the complex number. And when I say any operation, I'm saying addition, subtraction, multiplication, or division. So let's talk about what a complex number is. A complex number is an expanded number system beyond the real number system, which allows you to take the square root of a negative number. And this is used primarily with electrical engineering. So right now, if you try to type in the square root of, let's say, negative 25, it would say error, can't take the square root of a negative number. But you're going to now create a complex number system, which will allow you to do that. So first, let's talk about what a standard form of a complex number looks like. So it's going to be a number first. It's just a plain old number, and this is what we call the real portion of our complex. And then you're going to have this section which has the I in it, which is going to be called the imaginary section. So imaginary numbers, what they do is they allow you to work with square roots of negative numbers. So if I ask you to take the square root of negative 1 on your calculator right now, it would say error. Now on a graphing calculator, if you change the mode, hit the mode button, scroll all the way down to the bottom, and change it from the real to what we call, I think it's a plus bi, and then you type in the square root of negative 1, it will give you I, because that's exactly what I is. I is the square root of negative 1. So now every time you see the square root of negative 1, you're going to replace it with I. So the square root of negative 1 is I. Square root of negative 1 is I. Square root of negative 1 is I. Don't forget that. Okay, so we've already established that I is the square root of negative 1. Now, how we're going to use this is within a problem down here. So now notice how we can't take the square root of these negative numbers, but what we're going to do is we are going to, again, manipulate our square root of negative numbers into two square roots, with one of them being the square root of negative 1. So we can take the square root of the other one. So let's take a look at this. So I'm going to take the square root of negative 81, which I can't do right now, and I'm going to make two separate square root symbols. One of them being negative 1 and the other one being 81. Because again, if I join these together, it will be the square root of negative 81. Now we do this so I can actually take the square root of this like a normal problem, which would just be 9. And the square root of negative 1 is, we just learned that, I. So instead of writing the I9, treat that like a variable. We're going to write 9. We always write the I afterwards. And if you have a graphing calculator and you're in the right mode and you type in the square root of negative 81, it will go ahead and just give you this. Alright, so let's look at this one. This one's not a perfect square, so we're going to go back to our last lesson and reduce it. But first off, we're going to go negative 1 times 12. We always start off with that. Okay, so this is going to be just I. Now this section, unlike the other one was a perfect square, so we clearly got 9. This one's not so clear. So now what we have to do is reduce this square root, like we did in the previous lesson. Give me a perfect square that can go into 12. Give me a second to think. It should be 4 and then 3. We always put the perfect square one first. So the perfect square, square rooted, will be a whole number. So the square root of 4 is 2. The square root of 3 cannot be reduced, and you can't take the square root of it, so we're just going to bring that whole thing down. And then you've got this I. Well, I could write it like this, but that looks funny. I2 square root of 3. So we're going to write this section first, and then we always write a square roots at the end. So it's going to be 2I square root of 3. Now let's go back and talk about these. I said a second ago that if you type this in your calculator, it would give you that. If you type this in your calculator, it will not give you that because it's not a perfect square. So regardless, you're going to have to learn how to reduce these on your own. Alright, so let's talk about this for a second. So remember how I is the square root of negative 1. So I squared would be I times I, right? And I is the square root of negative 1 times the square root of negative 1. And we've established that when you square root something by itself, you pretty much just drop the square root and it's just that number. So I squared is going to equal negative 1. That's another piece of information that you need to know. I'm not going to tell you that in the future. I'll ask you, what is I squared? And immediately you should say, I squared is negative 1. I squared is negative 1. And keep telling yourself that. I squared is negative 1 until you get it down pat in your memory. So we've already talked about how to add and subtract these complex numbers. Now we're going to talk about multiply. Okay, multiplying is just like distributing. So if I gave you this kind of problem, okay, you would distribute. Same idea here. But you got to remember that when you see a square, that just means the parenthesis times itself. So we're going to go 3 minus 4i times 3 minus 4i. Alright, so let's go ahead and distribute. We're going to multiply this first 3 by each item in the second set of parentheses. So 3 times 3 is 9, and 3 times negative 4i is negative 12i. Now we're going to multiply the negative 4i times each thing over here. So negative 4i times 3 is negative 12i, and then negative 4i times negative 4i is positive 16i squared. Now let's combine any like terms. We've got like terms here in the middle. So it's 9 minus 24i plus 16i squared. Now remember, I squared is actually negative 1. So it's like this, 16 times negative 1. So if I multiply 16 times negative 1, that's just negative 16. So now here's the problem. So now I have like terms here and here. So we're going to go ahead and do 9 minus 16, which is negative 7. And then the I portion we're going to leave there at the end. And again, if you were to go ahead and type this in your graphing calculator in the right mode, it would just give you this. Alright, dividing complex numbers, there's two different ways. So one way is that the denominator is a monomial, so it's just a single term down here, nothing's being added or subtracted. What you're going to do is you're going to multiply both the top and the bottom by I. Because remember, I over I is like times something by 1, and if you times something by 1, it doesn't really change. We're just manipulating the problem so we can work with it. So this is a binomial and this is a monomial, so we're going to distribute. So 2 times I is 2i. I times I is I squared. Keep going with that numerator. I squared, though, remember, is the number negative 1. Alright, let's look at the bottom here. We're going to go 5i times I, which is 5i squared. And again, I squared is negative 1. So that'll give me negative 5. And this is fine. This is it. It's as far as we can take it. Because these are not like terms, I can't join them. I'm going to tell you an or because it depends on what kind of method the person that develops a problem might want to put it in. And a lot of these are in the ACT, so sometimes we'll put them all together as like one big fraction, and sometimes the choices are separated. So if you want to separate them, it's going to be this first top over this bottom. So it would be 2i over negative 5. And then it's this top over this bottom, which actually would be a positive 1/5 because those two negatives would cancel. So you just need to be prepared that it could be either way here. So when we divide, there's two different ways. One is if we only have a monomial down below. And the second way is if the denominator is a binomial, in this case like this. We have two different terms here. So we're going to do what's called rationalize the denominator. Now what that means is that you're going to multiply by the complex conjugate. here's what it means. So you're going to take the denominator, but you're going to change the sign in the middle, and that's it. So let's look at that denominator. The denominator is 3 minus 2i, so I'm going to take 3 plus 2i. And whatever I do in the bottom, I'm going to do the exact same thing on the top. And again, we talked about this earlier, that's because this whole top divided by this whole bottom is actually the number 1. And I'm not changing my problem by multiplying by 1. Alright, so let's go ahead and do this. You're going to see in just a few minutes that my issue of having an I in the bottom is going to go away. But you got to do it properly. So we're going to distribute the top. Then you're going to distribute this section. Okay, now we're going to distribute the bottom. Alright, now we're going to look at the whole top and see if we can combine anything. So we can combine these. And you need to remember that I squared is a negative 1. So that's the same thing as saying 10 times negative 1. So that will give me then 18 plus 27i minus 10. And then I've got like terms again here. So then 18 minus 10 is 8 plus 27i. Alright, let's look at the bottom. I can combine these. 6i minus 6i will cancel. And then again, I squared is really a negative 1. So we're saying negative 4 times negative 1. So we're looking at 9 plus 4. 9 plus 4 is 13. So we can leave it this way because I can't reduce these by the same number. But I'm going to have an or I could write it as 8 over 13 plus 27 over 13i. If I could reduce each of these, all of these, by the same number, let's say I could divide 8, 27, and 13 all by 2, then I would need to do that. So let's go back and talk about why we did this. The reason we came up with this complex conjugate, where we switched the sign in the middle, is so that these two in the middle would cancel out, and this I squared would become a negative 1, and you would no longer have the letter I. Because remember, back in the day, we said that we can't have the letter I in your denominator.